Beneath the red dust of Mars, NASA Curiosity rover has uncovered a landscape that looks like something out of a science fiction novel, a sprawling, honeycomb-like field of polygonal shapes. This isn't just a random pattern, it's a geological enigma. In June 2026, on its nearly 930th Martian day, Curiosity captured a 360-degree panorama revealing thousands of these geometric formations, more than ever seen in one place. These aren't just surface cracks, they're organized, symmetrical, and hint at a history far more complex than we imagined. What process could sculpt such order in the harsh Martian environment? Could this be a clue to ancient water activity, or something even more unexpected? As Curiosity continues its mission in Gale Crater, every polygon adds a new piece to the puzzle of Mars' past. What secrets lie beneath these shapes, and what do they tell us about the planet's evolution? The Martian surface is no stranger to polygonal patterns, but the recent discovery by NASA Curiosity rover has taken scientists by surprise. On Sols 4930 and 4931, June 19 and 20, 2026, Curiosity captured a 360-degree view of a terrain blanketed in these geometric shapes. Unlike previous sightings, this field is unusually vast and uniform. Researchers say such polygons on Mars are typically the result of thermal contraction or sedimentary processes, but the sheer scale and consistency of this formation challenge existing models. Consider the Miraflores Butte, a 20-foot-tall feature nearby, which sits within the same polygonal expanse. This suggests a large-scale geological mechanism at work. The patterns stretch across the landscape in a way that hints at deep, ancient processes shaping the red planet. As scientists analyze the data, they're beginning to piece together how Mars' cold, dry climate might have sculpted this honeycomb-like terrain. What this means for Mars' geological history remains an open question. In the heart of Gale Crater, NASA Curiosity rover captured an image of a terrain unlike any seen before. Over 4,900 Martian days into its mission, it revealed a dense field of polygons stretching across the landscape. These geometric shapes, some as large as a car, are not random. Their uniformity and sheer number suggest a process that required stable, long-term environmental conditions. Take the June 2026 images. They show polygons clustered so tightly that they resemble the cells of a honeycomb, a pattern rarely seen in Martian geology. This isn't just a surface oddity. Similar formations on Earth, like those in the cracked mud of dry lake beds, often form in the presence of water. Curiosity's findings hint that ancient Mars may have had a wetter, warmer climate capable of sustaining such processes. As scientists dig deeper into the data, the question shifts from if water was present to how much shaped this alien landscape. On Earth, polygonal patterns often emerge in places where water has long since vanished. Take, for instance, the cracked mud of ancient lake beds in California's Death Valley or the ice-rich permafrost of Siberia. Both showcase similar geometric formations. NASA Curiosity Mars rover captured a 360-degree view of an expanse of such terrain on June 19 and 20, 2026, during the mission's 930th and 931st Martian days. The rover has observed polygons before, but never in such density. The surface is covered with shapes ranging in size, some stretching several feet across. These patterns suggest a history of wet and dry cycles, or perhaps the slow freezing of subsurface ice. A recent report from NASA highlights the significance of these findings, noting how they align with known Earth analogues. Understanding these Martian polygons could reveal whether Mars once hosted lakes or rivers in this region. This brings us to the next question. What do these patterns mean for the planet's climate history? On Mars, the Curiosity rover recently captured an expanse of terrain marked by thousands of polygonal shapes. NASA reported this discovery on June 19 and 20, 2026, Sols 4930 and 4931 of the mission. The rover has encountered polygons before, but never in such density. These shapes range from a few centimeters to several meters across, forming a near-perfect mosaic. Back on Earth, similar patterns often result from freeze-thaw cycles in permafrost regions, but Mars presents a different story. Its thin atmosphere and lack of liquid water suggest other forces at play. Researchers suspect chemical reactions or unique atmospheric interactions might be responsible. Take the Miraflores Butte, for instance. Standing about 20 feet tall, it sits amid this polygon field, offering clues to the region's geological history. contrast between Martian and earthly polygons deepens our mystery. What shaped these features? The answer may lie in the chemistry of the red dust itself. Beneath the red dust of Mars, NASA Curiosity rover has uncovered a sprawling field of geometric polygons, each a window into the planet's distant past. Captured on sols 4930 and 4931 in 2026, these patterns are unlike any Curiosity has seen before, both in scale and density. Researchers believe these shapes could be the fossilized remnants of ancient climate cycles, possibly formed by the expansion and contraction of ice or the drying of wet sediments. Take the Miraflores butte nearby, capped with sand and surrounded by this polygonal terrain. Its very presence hints at a wetter, more dynamic Mars. Consider, too, that these polygons are not random. Their uniformity suggests a large-scale environmental process. This is more than a geological curiosity. It's a time capsule, potentially preserving billions of years of Martian climate history. And as Curiosity continues its journey, the story it tells may reshape our understanding of Mars' watery past. The Curiosity rover's Mars Hand Lens Imager, or MALI, has become an essential tool in revealing the red planet's hidden geometry. On sols 4930 and 4931 of its mission, it captured a sweeping 360-degree panorama, revealing a vast field of polygonal patterns, more than any previous observation. These shapes, some spanning several meters, suggest ancient processes of contraction and expansion, possibly linked to the loss of Mars' atmosphere. Consider the Miraflores butte, a 6-meter-tall rock formation nearby, where similar polygonal textures appear beneath a thin layer of sand. Such high-resolution imaging allows scientists to study erosion patterns and climate history with remarkable precision. The sheer density and uniformity of these polygons challenge earlier assumptions about Mars' geological activity. With every image, Curiosity paints a clearer picture of a world once shaped by forces not unlike our own. What these polygons reveal next could reshape our understanding of Mars' past. In the heart of Gale Crater, NASA Curiosity rover has uncovered an unprecedented field of Martian polygons, geometric patterns that stretch across the landscape like a honeycomb. Captured on sols 4930 and 4931 of its mission, these images reveal a concentration of polygons far greater than any seen before. The rover has documented such formations before, but never in such density. One prominent feature, a 20-foot-tall butte dubbed Miraflores, sits amid this vast network of shapes. Scientists are particularly intrigued because these patterns often form in environments where water once flowed. On Earth, similar polygons appear in permafrost regions or dried lake beds. This discovery could signal that Mars once hosted stable, liquid water, perhaps even for extended periods. If confirmed, it would reshape our understanding of the planet's climate history. The implications are vast, touching on the potential for ancient microbial life. As researchers dig deeper, they are preparing to shift the narrative of Martian geology. The discovery of a vast polygonal terrain by NASA Curiosity rover offers a compelling glimpse into Mars' watery past. These geometric patterns, observed in a 360-degree panorama captured on sols 4930 and 4931 in 2026, are unlike any Curiosity has seen before, both in scale and density. Researchers say such formations often form in environments where water once seeped through sediment, freezing and expanding over time. Consider the Miraflores butte, a 20-foot-tall feature nearby, capped with sand and surrounded by similar polygonal textures. These shapes suggest the ground once dried and cracked in a way familiar to Earth's salt flats or mudflats. A recent report from the rover team highlights how these patterns may point to a time when liquid water flowed across the Martian surface, shaping its landscape. This connection between polygons and past water strengthens the case for Mars' ancient habitability. As we look closer, the story of Martian water and what it might have supported begins to take shape. The discovery of a vast Martian polygon field has sparked a lively scientific debate. Researchers are split on whether these patterns stem from ancient ice, water, or chemical reactions. A recent report from NASA Curiosity mission, which captured this 360-degree view on sols 4930 and 4931 in 2026, shows the rover has found polygons before, but never in such density. Take the sand-capped but dubbed Miraflores, standing about 20 feet tall. It sits amid a terrain that looks almost like a honeycomb. Geologists suggest that if water once flowed here, it might have left behind mineral deposits that could support life. Others argue that shifting ground ice, similar to permafrost on Earth, could have caused the polygons to form. Still, a third group leans toward chemical weathering as the culprit. With no clear consensus, the debate continues. What's certain is that this pattern-rich landscape offers a window into Mars' ancient past. And that mystery is far from solved. The discovery of a vast polygonal field by NASA Curiosity rover in June 2026 marks a pivotal moment in Mars exploration. Captured on sols 4930 and 4931, the images revealed an area unlike any Curiosity had previously encountered. These geometric patterns, often linked to freezing and thawing of subsurface ice on Earth, could hint at similar processes once active on Mars. Researchers say such formations may indicate past environmental conditions conducive to liquid water, key for potential microbial life. Consider the Miraflores butte, a 20-foot-tall structure nearby, its honeycomb textures offering further clues. Understanding these features helps scientists map regions likely to preserve ancient biosignatures. Future missions, including sample return efforts, may prioritize such areas. This insight shapes not just where we look, but how we interpret Mars' history. As we prepare for human exploration, Curiosity's findings guide the path forward. Since its arrival on Mars in 2012, the Curiosity rover has operated for over 4,900 Martian days, navigating the red planet's harsh terrain with remarkable resilience. In June 2026, during sols 4930 and 4931, it captured a 360-degree panorama, revealing an unprecedented field of surface polygons, some as large as a car. This was no ordinary discovery. While Curiosity had previously observed polygonal patterns, this was the largest and most densely packed grouping ever recorded. The formations, resembling a honeycomb, suggest ancient processes involving contraction and expansion of the soil, possibly linked to water or ice cycles long since vanished. Consider the butte nicknamed Miraflores, standing 20 feet tall, framed by this intricate geometric landscape. This moment marks a milestone in Curiosity's decade-long mission. As the rover continues its journey, it leaves behind a legacy of groundbreaking revelations. What lies ahead may only deepen the mystery. The Curiosity rover, on its 930th Martian day, captured a 360-degree panorama, revealing an unprecedented field of surface polygons. These geometric patterns, previously observed in smaller clusters, now stretch across the Martian landscape in a density never before seen. NASA reports that these formations, some spanning several meters, suggest a complex history of thermal contraction and sedimentary processes. Consider the Miraflores butte, a 20-foot-tall structure nearby, capped with sand and surrounded by similar polygonal textures. This pattern repetition hints at widespread environmental conditions in Mars' distant past. Such conditions may have once supported liquid water, a key ingredient for life. The scale and consistency of this discovery offer scientists a rare opportunity to study Mars' climatic evolution. As Curiosity continues its journey, this find marks a pivotal moment, reshaping our understanding of the red planet's ancient history and its potential for habitability. The Curiosity rover, on its 930th Martian day, captured a 360-degree panorama, revealing an expanse of terrain blanketed in polygons, some as large as a car. This wasn't just another rock formation. It was the largest concentration of such shapes ever observed on Mars. Earlier discoveries had shown similar patterns, but never in such density. Researchers say these geometric features may hint at ancient processes involving ice or water, possibly even cryoturbation, a phenomenon seen in Earth's permafrost regions. Take the nearby butte called Miraflores, capped with sand and standing about 20 feet tall. Its base is surrounded by the same polygonal terrain, reinforcing the idea that this is no random occurrence. As Curiosity pushes forward, the polygons remain a puzzle waiting to be solved. If you're as curious about Mars as the rover itself, hit that subscribe button and explore more in the comments. Sources for this video are linked below.